In these examples, we are asked to do the following. Verify that the answer to the integral is correct. So we have the integral of sine squared x dx. And they say that this integral, if you do the calculations, you get that expression. So in this problem, they're not asking us to calculate the integral. They are asking us to verify that their answer is a correct answer. So what we're going to do is we take the derivative of this expression and see if it gives us that expression or not. If it does, then the answer is correct. If it doesn't, then the answer is incorrect. All right. So let's take the derivative of 1/2 x minus 1/4 sine 2x plus c. The derivative of 1/2 x is 1/2. Derivative of minus 1/4 sine 2x is minus 1/4 times derivative of sine 2x is 2 times cosine of 2x. That's the chain rule. The derivative of c is 0. So that gives us 1/2 minus 1/2 cosine of 2x. Well, this doesn't look like the integrand here. But wait, maybe we can check that. If we try to simplify this expression using trig identities, maybe we can come up with that expression. So let's work on that. So that's 1/2 minus 1/2. If you try to remember the double angle formula for the cosine, there were 3 options. Cosine of 2x is cos squared x minus sine squared x, or it's 1 minus 2 sine squared x, which is what we're going to use, or it's 1 plus 2 cosine squared x. So if we do that one, this will give us 1/2. Distribute this minus 1/2 in, so minus 1/2 times 1 minus 1/2 times 2 sine 2x is, 2 sine squared x is just sine squared x. The 1/2 and the 2 cancel. So this goes to 0. That gives us sine squared x. And sure enough, that's the integrand. So this verifies that their integral is correct. Alright, so let's do this one, second problem. So same way, we're going to differentiate natural log of absolute value of secant of x plus c. Well, the derivative of natural log of absolute value of x, we saw this in class is 1 over x. So this is just 1 over secant of x times the derivative of secant of x. Derivative of secant of x is sec x times tan x actually. The derivative of secant x is secant x times tangent x. Now the derivative of c is 0. So this secant cancels, so that gives us tangent of x, which is that expression here. So to verify that an integral that you calculated is a correct answer, you actually don't need to go to the back of the book to check the answer. What you can do is just simply differentiate your answer and see if it gives you the integrand that they gave you. All right.